HackZone, HackZone. HackZone, HackZone.
Well, I need to switch over to English, which is uncommon for me. I haven't done English presentations in about 3 or 4 years. My last one was at SHA 2017. So sometimes I'll talk Dunglish and with a horrible Dutch accent. So we'll have to cope, and I'll try and translate it back to Dutch again whenever needed. All right. So hi, I am Sebastius, also known in real life as Bas Oort. I have a Twitter handle, I have a Twitch feed where I stream occasionally. You can, I see all these remarks coming along on IRC fun. This is really distracting. I might close all the chat windows. I like soldering. It's a really ancient technique. It's about 5,000 years old. And I built tons of stuff with it. I repair tons of stuff with it. I used to repair MacBooks. Not nearly as good as Louis Rossmann did on his YouTube feeds, but it's still a lot of fun. And I build a lot of smaller and bigger projects. And Tom asked me to do a little demonstration on how you can do micro soldering easily and with the badge as its focus. So, but before we really go into soldering is addictive, very much. Yes, it is. I built tons of stuff. So before I go into what soldering is, I'll first illustrate what we're talking about. So this is the nice little CampZone badge. And if you take a look at the back, which you should always do, there are a bunch of components. Let me see if I can get it into focus. No, come on iPhone, you can do it. I'll maybe on this one. There's a bunch of components missing. I'll do it on the microscope and I'll zoom out a bit. There's a lot of components actually missing. So down in the bottom left corner, there is a bunch of components missing, which are labeled optional battery charger. Because CampZone went online, nobody needed a battery anymore. IC Palm, I'll get into the schematics, but we can post a link on the GitHub. So here's the complete circuit for the battery charger. If you want to build your own battery edition, you can. But in the audio circuit, there is also a little segment missing. And what happened here is that when they designed this thing, they had to cut some costs. And every cent counts when you're making badges. When you're making 500 badges, every 10 cents is 50 euros or something. So saving a few pennies on each badge sounds like nothing, but it comes down to volume. Yes, I will make a before and after sound comparison. We'll have a try. So they cut some cost, and we suspect that the audio quality is, oh, I am glitching out completely on Twitch. Oh, that sucks. That's completely useless. Oh, here we are again. Needs more keyframes. Yay, I am back. Oh, well. Looking at the video distortion that's happening. Yeah, it's what happens. Okay, so some parts are missing, and we're going to add those in and see what happens. I'll show you in the schematic what I'm talking about in a bit. But first, let's talk a little bit about soldering. Let's talk about soldering, because soldering is fun. And I've got Wikipedia in front of me. I'll wait a second until Twitch catches on. Yeah, there we go. So soldering is something you can really do a deep dive on using Wikipedia even. It's not the best source for everything, but it's a good start to understand the science behind the technology. And soldering is a process that's about 5,000 years old already. And that's insane. We're using a very primitive technology to do modern, well, to make your computer. That's 5,000 years of technological development has led us to being able to build laptops and smartphones and that sort of stuff. And that's cool. So soldering comes, the word, let me see if I can find it. No, I can't find it anymore. Doesn't matter. Soldering comes from the French word souder. I think that means something to join together. No, I can't find it anymore. So this was supposed to be a really informed deep dive with science and everything, but who cares? Let's go. Okay, so soldering. If you've never soldered before, here is the 1-minute intro. So I've got a little board. Oh, I need to switch my camera, sorry. So I've got this little board. I've placed a boring little component on it. I don't care. And what we want to make are little connections. I've got a soldering station. I've got the expensive one. You don't need an expensive soldering station. You can make do with a soldering station of about 30 or 40 euros. Oh, we're glitching again. Great. Oh, this program sucks. Oh, well, it's not our fault. It's not CampZone's fault. It's something in between. Well, I'll just wait with the show and tell. I'll just keep talking because I think the audio still continues on. It's just a video, right? Yeah, it's okay, Neon Effigy. That's fine. But I'll just keep on talking. So you don't need a 300, 400 euro soldering station unless you're doing this on a daily basis. You can make do with a 30 or 40 euro soldering station. There's even one rechargeable soldering iron at Action, I think for 10 euros, which is insane. I've had a USB soldering iron for 5 euros from AliExpress, which does somewhat of a job, but not really good. The main problem with every soldering iron is getting enough heat into the tip. You really want a consistent amount of heat in the tip of the soldering iron, and every time you try and make a connection, the tip cools down and it tries to replenish that heat. And if you have a good soldering iron, it really heats up, reheats fast enough. And if you have a bad one, it cools down to the point where you can no longer solder anymore. So that's a soldering iron. So get one for, if you're doing this as a hobbyist, 30 or 40 euros is more than enough. So next up is solder wire or solder. The English, you say solder, the Americans also, I think, but there's an L in that word. And there's roughly, for electronics, there's 2 kinds. Yeah, I will tell you about how much heat for what. That's going to happen. So there is basic leaded solder. I have some more. And there's lead-free solder. And that's different. So I'm going to science the shit out of this. So I'm going to switch back to Wikipedia. And I'm going to talk a little bit about that. So, oh, there it is. That's solidare. That's the Latin word, actually, to make solid. Wow. So turns out soldering used to be pretty toxic because we use an alloy, a solder alloy made out of lead and tin. In Dutch, we say soldeer tin, which doesn't really cover everything because it just describes the tin. But normal solder, the old school stuff, I'll switch to my camera again. There you go. Just now I'll put it on the microscope. There is. So here you see SN60 PB40, SN stannum, which is tin, and PB plumbum lead. And so this alloy is 60% tin, 40% lead, which is cool, but it's rather toxic. And the problem is with human bodies, they can accumulate lead, but they cannot get rid of it. So if you keep on getting more lead into your system by handling all these bits and then putting your hands to your mouth or whatever, same as like with the coronavirus, you are slowly killing yourself or making yourself insane. It's what the Romans did. They had their wine stored in barrels covered in lead, and because it's a very nice material, and you're basically slowly killing yourself and the environment. So by law, we are now in professional equipment required to do lead-free soldering, and this is one of many. And yes, the image is crap. We know. I'll just keep talking, and the image quality will get back up again. That's fine. I'll just keep on chatting away. So by law, we are now required for professional production to use lead-free solder. So if you're doing anything commercially, you're in small or big volume, you're supposed to do it without lead, which is good for everyone. There are conspiracy theorists claiming that lead will, unleaded solder will be more brittle and break more often, causing you to buy more devices, etc., etc. That used to be the case. Yeah, 5G. Yeah, the camera glitches are 5G. That's got to be it. Also note, even though I've handled my solder, I'm picking up my glass at the bottom, so I'm not trying not to contaminate myself. But then again, I've probably ingested more lead than I would really like. Okay, so let's make a connection. And I'll use lead at first, and I'll use lead-free too, and I'll use flux, and I'll use all those little things because we are rapidly running out of time, and I still need to actually solder on the CampZone badge too. So I've got my board, I've got some heat. This is leaded solder, so I'm going to heat to 320 degrees centigrade, not funny units. And basically what you're doing is heating up the pad and the pin, adding a little bit of solder, and there it goes. I'll try and get a more close-up. The closer you get, the nicer it is to see what's actually happening. Ah, this is better. Unless it glitches out again. And there's the Jinx already making lots of comments about more sciencey stuff. So what you're seeing, that when you hit the solder to the heat, that it starts to look a little bit like a liquid. It melts, and that it grabs onto stuff is called wetting. It gets wet, quote unquote. So here we go. And that wetting is interesting because that happens because of flux. In your solder wire, in every solder wire we use for electronics, there's also a little bit called flux in Dutch vloeimiddel. And flux makes wetting happen. It's slightly acidic, so it cleans off some oxidation from the metals, and it really enables the stuff to get stuff to connect. So if you really, if you want to do more sciencey stuff, I recommend you, if you're in Dutch, you can watch my YouTube video I made on some soldering. I did a lead-free special a few weeks ago. But just read some Wikipedia. That's fine. Okay, so let's try some lead-free, because Tom is claiming that leaded is so much better. Well, it's a little bit less. It's a little bit more difficult to work with lead-free, but it's fine. I'm heating up to 350. I don't know if that's the exact temperature I need, but we'll try it out. And it's hot because I've got the expensive soldering station here. And here we go. And heating it up, letting the air bubble out a bit, and done. And what you see is a slight difference between the top one and the bottom one. I hope it's not glitching out. I'll zoom in a bit further. And focus the microscope. So what you're seeing, the difference between the top one, the leaded one, and the lead-free one, is that the top one is nice and shiny, and the lead-free one is a little bit more hammer, not shiny. It looks a little bit like it's metal with a hammerslag. It's called in Dutch. What do you call it? Like that hammerite paint you put on fences. That's just a bit more faceted, but still a good connection. All right. So that's basic soldering. Just heating stuff up and making it stick. All right, CampZone badge. And let's switch over to the schematic so we all know what we're talking about. So if you go to the HackZone GitHub, github.com/HackZone, and download the schematics in the repository, and go to the audio circuit, and this is where we are. So this is the entire audio circuit. And Tom is very proud that the audio, the entire audio circuit, from the digital to analog converter and the parts in between and the amplifiers, quote unquote, cost 10 cents in total. Yes, he spared no expense. In comparison, the audio chip we used for the Hacker Hotel badge in 2019 costs about 70 or 80 cents, just the digital to analog converter. So this was a really nice, affordable way to make audio happen. And so this on the left, I hope you can see my mouse cursor too, is the digital to analog converter. I'll zoom in a bit. So it gets I to S audio or digital signals, and then it poops out 2 analog signals, and 2 op-amps, I think, do the amplification towards the speakers on the right-hand side. Okay, but if you zoom in, there is something interesting. A few bits, the 3-volt power circuit for the audio path, are not populated. It says DNP, do not populate. So C26 is not populated, U12 is not populated, C27, and there is a resistor here. That's basically a jumper to the rest of the 3.3 volt circuitry on the badge, and the other one is not populated. So R28 is populated and R30 is not populated. And what we're going to do today is remove this resistor, cutting the audio circuit off from the rest of the power circuitry, from the other regulators that's already on the badge, and giving the audio system its separate regulator with its separate capacitors, and hopefully make it a little bit less glitchy. No guarantees though. And smoke might erupt as this circuit has been untested. Well, they might have tested it in the preview stages, but whatever. Okay, so that's what we're going to do. And I need to keep this close as I need a reference of what I'm doing. And now let's show you in the PCB. If you get the PCB layout, this is the CampZone badge. I've removed all the traces so we can actually see what we're doing. And if I recall correctly, it was U12. That's here on the left. So this is U12. I need to place that one on C27, C26. Those all need to go on, and I need to move the resistor R28. I need to remove that one and populate it on R30. All right, so 1, 2, 3, 4, 5 parts in total. Okay, that sounds doable. Let's go full screen microscope. Or wait, let's do this one first. So I'll show you some more setup before I do that. Okay, this is pristine, unused, still factory settings CampZone badge. I haven't done anything with it. I've just unpacked it. And let's have a look where we need to go. And here we are. So let's compare what we see on the microscope. I'll show you with a nice sharp tweezer. So here's R28. That needs to move to this position, to R30. We need to add 2 capacitors. Here's C27, C26, and we need to add U12. Okay. Is this camera software of the microscope? I don't know what you mean, Yillis. This is just an HDMI capture of the microscope. Okay, so what I'm going to do first is I'm going to pull off this resistor. Then I'm going to clean all these pads because there is already solder on there. I need to make them nice and flat. And then place new stuff on there. And I don't know. Tom sent me a nice little bag full of drugs. I mean components. And I hope that, oh, the 10 ohm resistor is there, so I can just pull off the R28. Okay, so this is interesting because we're actually going to do Smd Rework. It's the HX9193-33GB. I'll type it in the chat. HX9193-33GB. Here you go. So let's make some mess. And I'm a lazy solderer, so I'm just gonna muck about with it. And I'm gonna get a little less heat. So if you overheat pads, and that's extended heat for a longer duration of time, stuff will start to fall apart. But I'll need to get the angle right so you can see and I can work. I'll use some heat on this one, use some heat on the other end. Okay, and it's almost gone. Yeah, goodbye. So what I did was I just added some tin, some solder, and I heated both sides of the pad and it was gone. Okay, so that's one. Now I'm going to want to clean all these pads, so I'm going to add some solder, which is counterintuitive, I know. But trust me, when you're cleaning up a lead-free circuit, it's easier to just add a little bit of leaded solder, lowering the melting point, and then getting stuff off. I'm also going to use some flux. I'll show you that in a bit. I use Chip Quick SMD 291NL. That's a no clean tacky flux. Tacky means and now I'm going to use some desoldering braid. That's this kind of stuff. And this is, okay, I should use 1 microfarad caps instead of, that's already spec'd. The 1 microfarad is spec'd in the schematic. So yes, I am. So this is solder wick, W-I-C-K, I think, or maybe an H somewhere. And this is already fluxed copper strands. And what it does is it sucks up solder. Because of the flux, it makes the solder flow nice. And if you heat it up, you can just, without pushing, do this gently. Looky, looky, here we go. Very pretty. That's more like it, nice and flat. Yes, this is black magic. So now what we can do is 2 things. We can solder these on using regular solder wire. We can also use hot air and solder paste. I'm going to use the solder wire just to demonstrate that it's easy enough to do with these kinds of components. And I'm going to switch the tip of the soldering station. I'm going to switch to a little bit smaller tip. You don't actually need it. Oh, wait, I can probably do it with the wide angle tip just to prove that this actually works better for most cases. Okay, so I need, let's go check my schematic. I need to move a 10 ohm resistor at R30. Let's do that first. I'm gonna work my way from R30 to C27, which will be annoying because they're really tied together. And then I'm going to do U12, and then I'm going to do C26. Okay, let's get all the drugs out of the little bag. Am I saying that on live stream? That's not really clever, is it? Okay, so SMD components come in these little strips. This is 0603 size in Imperial. Oh, and it's just a little bit above the grade of sneezing powder. 100. Oh, wait, am I doing this wrong? Or did you label it wrong, Tom? Or does it say 001? What does it do? Oh, wait, so that's 10 ohms with 0. Yeah, I know. It's 10 with without extra zeros attached. That's fine. So R30. And let's do this. I'm going to add a little bit of solder to one pad. And I'm going to grab it by the fur. Add a little bit of heat. Okay. Let's do the other side. So there is still flux on my board. And that's more than enough. So that's R30 done. Let's try it. Nice and tight. If you clean this up, you'll hardly see that anyone hand soldered it. It's a little bit more shiny than the lead-free stuff the factory used, but that's fine. Okay, so let's see, what else do we have to do? That's the, so what we've done now is that so what we did now is that we switched our audio path to a separate separate track. So it's now in its own power circuitry, if we actually add the required power circuitry. 1 microfarad, a very small bicycle we're going to add. Ein Mikrofarad. And I'm going to grab 2 of them, so I'm going to need 2 of them anyway. Here we go. Let's see, a small bicycle and another small bicycle. Sometimes when I do the soldering, I go full Bob Ross and say, happy little capacitors, that sort of stuff. And let's, because this is something you want to learn, let's also here's 1 capacitor. Let's try and make a boo-boo. Let's try and fuck up. Oh no, I'll do the fuck up on the chip. That's nicer. I'll simulate a fuck up by actually fucking up, and then I'll probably break stuff, but that's cool. So, more than enough solder. So, if you get tiny little whiskers or something, pointy bits sticking out, you're not using enough flux. I'm still on the flux I got on when I was desoldering this board, but if you get pointy bits, you're not using enough flux. I cannot simulate it at the moment because it's already drenched in flux. It's hard to understate the amount, hard to overstate the amount of flux you need. You always need more flux. And it's easily washable, so just add more flux. Flux is your friend. So here is C26. That's a little bit too much, but that's okay. Clean my tip. And what you've seen me do so far is that I've used these really wide chisel bits for soldering. Yeah, Mars stream. Yeah, I'm missing this. Is it it's going to launch in a few minutes, right? Crap, I need to hurry up because I also want to see that. There's three little robots with some soldering in it heading to Mars, which is cool. Oh, here we go. Here is our guest of honor. Probably the cheapest 3.3 volt regulator Tom could find. Well, at least he added capacitors on this batch. And it's going to live right here. So I'm going to give it some room. And I'm going to make some boo-boos. Let's first give it a spot to live in. So I'm going to heat up, drop it in place. Here you see what's happening when you're running out of flux. It's not that bad actually, but see that little point? Oh, that capacitor is also nice and crooked. Oh, there's several rookie mistakes I'm making. Cool, which is good. So the capacitor in the back has lifted up on one side while I was soldering it. So it's a little bit at an angle. It's still attached, so at this point in time, I do not care. This one is when you run out of flux, you get these nasty points. And that should just be a matter of, well, as I said, adding more flux. Let's get the syringe. There we go, nice drop of flux. And heat it up, and there we go, that's better. That's a lot nicer. I'll do the other one, and then I'll make a screw up on the other side. I want to show you how to fix boo-boos. Nice connection. Let me check. Yeah, that looks nice and solid. It's a beaut. The cheapest low dropout voltage regulator you could find. Yeah. Yeah, else you would just be generating heat if you didn't use a low dropout regulator, right? Okay, so on this side, I'm going to be clumsy. I'm going to be, oh, goodness me. Let's add some more. See, the flux is so good that it's hard to actually make this mistake. I want to connect all 3 pins. Yeah, there we go. So you've been soldering and then you looked at it and then you go like, eh. This happens to people. It happens to me too. And it's not bad. It's easy fix. Let's first clean up this little, where are we? This would have caused a problem later on. So when you've got these bridges, T-minus 6 minutes till launch. Cool. I hope to be done by then, but that's fine. First thing you do is add a little bit of flux. That's already drenched, I know. I still want more flux. You get a clean, really clean tip. Just use the metal curly things or the sponge or whatever. When you use a sponge, don't make it soaking wet. Moist, not wet. But when you use the curls, just clean it with the curls. Okay, so what I'm going to do is heat it up and drag away. And again, heat it up and drag. Let's try this a few times. Come on. So you see for the first one, it already worked. And for the second one, there we go. So no additional tools required, just a little bit of dragging and dropping. So, all right. We have now one fully modified CampZone audio system, I think. And yes, it's a little bit dirty. Normally you use some isopropyl alcohol to clean up, and some maybe a cotton swab or something. The problem is I don't have cotton swabs because one of my cats, Gadget, really loves cotton swabs. And he will go to great lengths to capture one and then run away with them. So, and tipping over boxes and digging in stuff. And that's really annoying. So I don't have cotton swabs at the moment. Yes, Gadget is a very good boy. Very naughty little good boy. Okay, so let's switch over this to that. Let's plug in an audio. Okay. And let's make some room. We don't need the microscope at the moment. So what we're going to do is this one already worked, so I don't need to test it again. So I only have one USB-C cable because I really prepared for this workshop. Yeah, Gadget is cool. Sometimes I just do Twitch streaming of him sleeping on the couch and people love it. This was an untested batch, so let's hope it works. Windows says bleep. So let's see what it does.
Welcome to your CampZone badge. Start apps with a short press. Hear their name with a long press.
Okay, I'll have a listen myself. Okay. Let's see what happens. Oh, this doesn't contain any actual LEDs. Green button, top right. Okay. So, all right, this is interesting. I need to put this back on my head. So yes, it is different. The audio is different. Before it had a lot of little static through it, pop, 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 on a rhythm. That's all gone. So it's just a monotone hiss right now. So it has improved. Let's try the other one. I don't know if that one has the actual MIDI app, but let's try it on. Let's see if this one has any. No, sorry, Tom. It sounds exactly the same. Okay, let's try it. Let me do it again. Really bad at double blind testing. Come on, CampZone badge, startup. It really has a nice startup. No, it's exactly the same. Oh well, we tried. But the weird thing is I didn't get the pulsing audio on the first one as well, so I don't know what happened. Might just be me. I'll do some more testing. But anyway, it was a nice little soldering workshop. And now my CampZone badge is a little closer to being as designed, not as built. It was funny. Ah, well. Yep, little difference. Might be improving. I'll do some more testing and I'll let you know on the Twitter, but I think nothing really happened. What I think the problem is with the audio, well, the problem, it's a 10-cent audio track, but it might just be that all that LED power is coursing right underneath the audio circuit. So that's completely fine. I still have 10 minutes. Yeah, sure. All right. Let's do some Q&A. If you have some questions, if you want to ask me stuff, there's actually people also poking me through IRC. Yeah, the how dirty the USB power supply is. Yeah, this one, it's now connected to a nice little USB hub. No cat loaves. No, there's no actual cat inside here. They fled. Did you get the DEF CON Save badge? I wish I did. I really want that tape. There's a copy on archive.org. What's my opinion on missing the NASA launch? Yeah, fuck. Did they launch? Did it work? Did it not explode on the pad? Let's click a link. Let's see what happens. Oh, it's already flying. Ah, that's a thing of beauty. Still, well, if it survived 2 minutes, then we're doing very well. I mean, yeah, that's pretty nice. Cool. So, any questions? If you want to know anything about soldering before the director comes in and tells me to kill my stream, etc., let me know. We can do some stuff. I just don't know what you want me to do. It was a boring launch. Yes, that's the good launches. Is this to be continued with badge mods? When would you use solder paste instead of tin? Never. No, that's not true. I use solder paste when I use hot air. So when you're doing populating an entire board, I have it right here. I'll show you. When you're populating an entire board, you can use solder paste, which is, I'll zoom in on the microscope. Let's see if we can get it all the, that just looks disgusting. It doesn't look like anything. But what you can imagine that the solder paste is a suspension of flux and small balls of solder. If you heat it up, it nicely melts and the flux evaporates and your connection is made. And when you're doing a whole board in a reflow oven or with hot air by hand or with a hot plate or whatever, that's always nicer. How do you maintain and prepare your tip? Well, when it's broken, just buy a new one. But the main thing I just do is don't abuse it by melting plastics. Don't overheat. And I use the metal curls currently. I used to have a wet sponge. I like the curls a little bit better. The curls have one problem, is that they don't cool down the solder on there. So when you sometimes hit the curls a little bit more aggressively, it can bounce back. How do you know the temperature for it to use solder? Well, when you buy the good stuff instead of the crap stuff, you can just look it up. It's let me get, where's my rolls of solder tin? So you can just I buy my stuff from Stonnel, and they have data sheets.